Okay, here the recording in progress. So we'll share the screen. Okay, I'm actually pretty much finished with 11.8 by today. If not, I can sneak that into Monday, which means I'm almost an entire week ahead. So we'll see how it goes. I'll give you the quiz. Again, we actually are going to have another quiz on next Wednesday just before Thanksgiving. And then our last quiz is on Friday, the 3rd of December, I guess. Okay, so I'll show you the quiz, do some more problems on 11.8, and then that'll be just about it. Okay, next week we only have 3 days, Thursday and Friday are holidays, and before you know it, we'll be finished with everything. Okay. All right, so let's get ready for the quiz. I'll show that to you presently. So you can have your cell phones ready or be ready to do a screenshot. Okay, here we go. Let me make it a little bit smaller so it can be more readable. Okay, all of these should be done by the ratio test. So you might think of this as a ratio test quiz, essentially ratio test. Number one, determine if the series converges or diverges and state why. Well, the why is the ratio test, pretty much. Okay, that's more like section 7. 2 and 3 are like section 8. Notice there's an X here. There's no X in problem number 1. 2 and 3, there's X's, which means you have to determine a radius of convergence. How much do I go left and right from the center? And the interval of convergence. Okay, so number 1 was n squared plus 2 over 3 to the n. Number 2, negative 1 to the n, x to the n over n squared. Determine the radius of convergence and interval of convergence. And likewise 3, find the radius of convergence and interval of convergence. Summation x to the 4n over n factorial. Okay, all of them to be done by the ratio test. So you know how you have to give a reason for all of these. For this one, it's easy. It's all ratio tests. Now, I'm not going to be that generous on the exam, perhaps. I'm not going to say, oh, this is definitely ratio test. This is definitely limit comparison test. This is definitely integral test. You have to figure that out on your own. Okay, but for this one, I can go ahead and share with you. It's definitely all ratio tests. Okay. All right, so I'm going to make this disappear now. Hopefully, you've already taken a picture or screenshot. If worse comes to worse, watch the video later. Open everything, but again, when I say open everything, you have to do it like we've done it in class. I mean, some of you look up stuff or ask friends or ask somebody else for help, but it's not done the way that we did in class. You have to do it the way we do it in class. It's probably the best way for me to say that. Okay, so there you go. Other than that, yes, it is open everything. Due at 11:59 p.m. tonight. And that's that. Okay, so I'll make this disappear now. And I'll do some more problems. And then hopefully quit early so you can get going on the quiz. All right, so put this away. And get back where we were. So I'll do some more problems from section 8. Okay, problem 23. Summation n equals 1 to infinity, n factorial, 2x minus 1 to the n. Reminder for 11.8, there's an x in all the problems, just like question 2 and 3 in the quiz. Notice there's x there, right? There's a variable. We're centered somewhere. So like the one we're doing 23, we're centered at 1/2. 25, we're centered at 4/5. Okay. Something like 9, you're centered at 0. 5, you're centered at 0. 3, you're centered at 0. It doesn't go x plus something or x minus something, right? 15, you're centered at 2. 17, you're centered at -2, and so on. Okay. So for this section, there are 3 cases. Put this on your cheat sheet if you wish. Number 1, convergence only at x equals a, where they're centered. 2, convergence for all x. We've already seen that. And 3 is the most normal case. There's a positive number r called the radius of convergence. I know radius sounds weird in 1 dimension, but that's the 1-dimensional analogy of radius in 2 and 3 dimensions that you're familiar with, right? In 2 dimensions, radius of a circle. 3 dimensions, radius of a sphere. Well, in 1 dimension, we have a number line, start at a point, and say go the radius in every direction. Well, there's only 2 directions, left or right. Okay. So you have a radius convergence where you have absolute convergence in the middle. the two extremes, you have divergence, and then the two endpoints, you can't say for sure. So this is the figure 3, the quote unquote most normal case. Centered at A, you go R units to the left, R units to the right. Everything in between, you have absolute convergence. Everything on the two outsides, you have divergence, and those two endpoints you have to check separately. Okay. Series 23. This one does not have any fraction. So for a sub n plus 1 over a sub n an absolute value, n plus 1 factorial, 2x minus 1 raised to the n plus 1 over n factorial, 2x minus 1 n, just literally divide by a sub n, right? Okay, this divided by this is n plus 1. Hopefully you see that by now. This is 1 times 2 times 3 times dot 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 times n. This is 1 times 2 times 3 times dot 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 times n plus 1. So everything cancels out except for the n plus 1, right? And then this, by normal rules of exponents, is 2x minus 1. Okay, now look at this. Now, n goes to infinity. No matter what x is, if this result is non-zero, this thing's going to go to infinity. Okay. Let's pretend I plug in 0. You have negative 1 whose absolute value is 1. And then n shoots to infinity. This thing's going to approach infinity. That's always going to happen except for one number. That one number is where you're centered at a half. If I plug in a half, this is 0, right? So no matter what I plug in, it's going to be 0. So here's a case where you have convergence only at a single point. So if you play the same game as before, you're centered at a half, and then how far do I go left and right? Well, you go 0. So the radius of convergence is 0. The interval of convergence is just bracket 1/2, meaning the set consisting of 1/2. So you don't even write an interval as we normally do, right? So you don't have to do brackets or parentheses. It's just a single point. So remember we said we're guaranteed convergence at one point, the center. Here is that case where you are guaranteed convergence only at one point, only at 1/2. Okay, because if you plug in any number besides a half, this is non-zero. Any non-zero number times this is going to shoot to infinity as n goes infinity. Okay, so that's always going to be true except for 1/2. So here's the case where the radius of convergence is 0. So you're centered at 1/2. So how far do I go left and right? I don't go anywhere. So the interval of convergence isn't really an interval, it's just a single point, 1/2. Okay. Okay, going back and doing some others. 15, summation n equals 0 to infinity, x minus 2 to the n over n squared plus 1. Okay, so this one is centered where? 2. So I know it's going to converge at 2. I don't know about anywhere else. Okay, jumping ahead, this is what it ends up looking like. Okay, so you're centered at 2. You go the same distance left and right. So how do we establish that? Okay, again, we'll do the ratio test. A sub n plus 1 over a sub n. This one is a fraction, so change that to n plus 1, change that to n plus 1, times the flip of this. So reciprocal of that, n squared plus 1, x minus 2 to the n. Okay, this is n squared plus 2n plus 1 plus 1. And that divided by that is just x minus 2. And yeah, when you have problems like this, you can just go ahead and say, this limit is 1 as n approaches infinity, right? When n gets super big, the plus 1 is insignificant, the 2n plus 2 is insignificant. It's basically n squared divided by n squared, which is 1. Okay, times x minus 2. So this approaches absolute value of x minus 2 as n approaches infinity. By the ratio test, when will this converge? Well, when x minus 2 is between negative 1 and 1. Add 2 to all three of them. And when x is between 1 and 3, I definitely have convergence, right? So my radius of convergence is 1. Everywhere in between, I have absolute convergence. Here and here, I have divergence. And then I don't know about 1 and 3. It looks like I colored them in, so evidently it's going to converge at the two endpoints. But right at the start, you don't know. Remember, we're doing the ratio test. Okay, so suppose I plug in a number in between here, like a 2.9. 2.9 minus 2 is 0.9. That's less than 1. So absolute convergence by the ratio test. How about if I plug in, let's say, negative 2? Negative 2 minus 2 is negative 4, whose absolute value is 4. That's greater than 1. Divergence by the ratio test. But what happens when you plug in 1 or 3? Plug in 3. 3 minus 2 is 1. Absolute value is 1. Ratio test fails. Plug in 1. 1 minus 2 is negative 1, whose absolute value is also 1. Ratio test fails. So, I mean, that's pretty good. The ratio test can cover all real numbers except for 2. I mean, there's a lot of real numbers, infinitely many. The only numbers where the ratio test fails are 1 and 3. So I just test 1 and 3 separately. So how do I do that? Just plug in 1, plug in 3. So back in the original, plug in 1, plug in 3. So plug in 1. 1 minus 2 is negative 1. Negative 1 to the n over n squared plus 1. That converges by the alternating series test. It's alternating. Absolute value of a sub n decreases. A sub n approaches 0. Plug in 3. 3 way back over here. 3 minus 2 is 1. 1 to the n is 1. 1 over n squared plus 1. I compared it to summation 1 over n squared, which converges. It's a p series. P equals 2, which is greater than 1. And I know 1 over n squared plus 1 is less than 1 over n squared for all n. Okay. So the series converges by the comparison test. Okay. The bigger series converges. So anything smaller converges. All right, so my radius of convergence is 1. Interval of convergence is bracket 1, 3 bracket. So again, you could have the two endpoints open, open. We've seen that. Close, close. We've seen that. Or one of them open, one of them closed. All of those are possible. Okay. All right, 27 is that weird odd factorial like thing. X to the n over 1 times 3 times 5, out of that 2n minus 1. So it's not a factorial. Factorial is 1 times 2 times 3. This is kind of like an odd factorial. You only multiply the odd factors, 1, 3, 5, and so on. Okay, so still do absolute value x of n plus 1 over x of n. So this one, change that to n plus 1. Change that to n plus 1 in parentheses. So x of n plus 1, 1 times 3 times 5, da da da. 2 parentheses n plus 1 minus 1 times the reciprocal of this. So the top has 1, 3, 5, the bottom is x to the n. Okay, now if you work this out, it's 2n plus 2 minus 1. 2n plus 1. So the next step, leave that alone, leave that alone, leave that alone. This is 1 times 3 times 5, da da da, 2n plus 1. What is the factor just before that? Well, these are 2 apart, so the one just before has to be 2n minus 1. Okay, when I do the dot, 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 remember there's stuff leading up to it. If the last one is 2n plus 1, these are 2 apart, this one has to be 2n minus 1. Okay, and now notice all of these cancel all of these. And then I have that divided by that, which is just x. X to the n plus 1 minus n, x over 2n plus 1. Okay, and now keep in mind, even though x is a variable, it can be 37.5, a billion. You can make it as big or as small as you want. The bottom is going to shoot past it because the bottom moves. This is a fixed number. So the game is like, you give me any x at the start, it can be super big, but it's a fixed number. The bottom is not fixed. It gets to move to infinity. So the bottom will eventually win. So this approaches 0 as n approaches infinity for all x. Right, so here's another case where r is infinity, I is negative infinity to infinity, which means all real numbers. Okay, so we're centered at 0, right? So how do you know it's 0? It doesn't have parentheses x plus 2 or x minus 2. You can pretend it's x minus 0. So I start at 0, and how far do I go to the left and the right? You go infinitely far, which means you have all real numbers. Okay. Now, 21 might be a little bit trickier just because you see a bunch of variables. 21, n over b to the n, x minus a to the n, where b is greater than 0. Okay, well, just faithfully do the same thing anyway, even though you see a and b there. Okay, Now, when it's written like this, where are we centered? Centered at A. Okay, and you can see, looking ahead at the answer, there's A, I go a certain amount to the left and to the right. Okay, so ratio test. A sub n plus 1 over A sub n absolute value. Change that to n plus 1. Change that to n plus 1. Change that to n plus 1. And just flip this original, b to the n, x minus a to the n. That's funny, this should be n plus 1, b to the n plus 1. That's a little bit bad there. That's an n plus 1 also. Anyway, okay, n plus 1 over n. Look at the x minus a stuff. These two. So I have x minus a on top. Then look at the b stuff. B to the n plus 1. I have a b in the bottom. Okay, and now let n approach infinity. This thing approaches 1. So I have absolute value of x minus a over b as n approaches infinity. When will this converge? Well, when the thing behind my finger is less than 1 in absolute value, which means it's between minus 1 and 1. So negative 1, positive 1, x minus a over b. Multiply both sides by b. Okay. B is a positive quantity. That's why they had that. For if b were negative, you might have to switch the inequality symbol, right? But b is positive, so I can keep the same signs. Negative b less than x minus a less than b. Add a to everything. A minus b less than x less than a plus b. So the radius of convergence is b. So here we are, center to a. I go b unit to the left and to the right. A minus b, a plus b. Absolute convergence here, divergence here and here, and we don't know here and here. Evidently, I left them open, so that seems to imply this is the case where we have divergence at both endpoints. But let's actually see it. Okay, so I plug in x is a minus b. So back here, I'm going to go a minus b, and then minus the a, right? So a minus b minus a, that's negative b to the n over b to the n. That's summation of negative 1 to the n times n. That diverges by the test for divergence. The a sub n's do not approach 0. Okay, so we start with n equals 1. Let's see, n equals 1, that would be odd. So it's negative 1 plus 2 minus 3 plus 4, and so on. That diverges by test for divergence. We do not approach 0 for a sub n's. And how about the other endpoint, a plus b? So plug in a plus b right over here, a plus b minus a. So summation n over b to the n, a plus b minus a to the r. A's cancel out, you have b to the n. Well, that'll cancel that b to the n. So I have summation of n. 1 plus 2 plus 3 plus 4. That diverges by test for divergence. Okay, what is test for divergence? If the a sub n's do not approach 0, this is 1 plus 2 plus 3 plus 4, that blows up. Okay, so you automatically have divergence. Okay, and watch out again, if a sub n does approach 0, that does not guarantee convergence. Okay, it still might diverge. And our basic example for that was the harmonic series. Right? Harmonic series, 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, that diverges, in fact, diverges to infinity, even though the individual terms approach 0. Okay, so my radius of convergence is b. The interval of convergence is parentheses on both sides, a minus b, a plus b. Okay, 25, and then I'll be done. And then I'll quit. Then I'll let you ask any questions. And if not, I'll let you get started on the quiz. Summation n equals 1 to infinity, 5x minus 4 to the n over n cubed. So this one is centered at 4/5. You basically just set this equal to 0. Set it equal to 0, do a little bit of algebra, right? Add 4, divide 5. centered at 4/5. So I'm guaranteed convergence at 4/5. Maybe that's all you get, right? That other problem we did today, convergence at 1/2. It turns out that was it, just 1/2. So if case 1, convergence only at the center. Case 2, convergence for all real numbers. We've seen that. But the most normal case is 3. You have convergence on an interval, right? So in between, absolute convergence. The 2 outsides divergence, and you check the 2 endpoints separately. Okay, ratio test. As you might have supposed, you might think, oh, it looks like we're doing ratio tests quite a bit. You're right, which is why I give you a whole quiz on ratio tests. Okay, a sub n plus 1, n plus 1 there, n plus 1 there. Divide by a sub n, multiply by the reciprocal. Okay, so I put the n stuff together, n cubed over n plus 1 cubed. And then the 5x minus 4 stuff, that divided by that is just 5x minus 4. What do we approach as n approaches infinity? That approaches 1. For these kind of problems, you can just go right to it. You don't have to actually work out limit n approaches infinity. You could do L'Hopital's rule and all that, or divide top and bottom by n cubed, but this is fine. This is 1. Plug in a billion. A billion divided by a billion and 1 is practically 1. Cube it, it's still 1. Right? So that approaches absolute value of 5x minus 4 as n approaches infinity. So when will this thing converge? When the thing behind my pen is between -1 and 1. Okay, then solve for x. Add 4 to everything. 3 less than 5x less than 5. Divide by 5. X is between 3/5 and 1. And what's right in the middle between 3/5 and 5/5? 4/5, which is what the center is supposed to be, as we anticipated, centered at 4/5. So the radius of convergence is automatically 1/5, right? 1/5 of the unit that way gives me 3/5. 1/5 that way is 1. Absolute convergence here and here, divergence here and here. And these 2 points, we don't know. Looks like I colored them in, so it looks like they're going to converge at both endpoints. Okay, so you could have open, open, close, 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 open, or open, close. We've seen cases of all of them. Evidently here, they're both going to converge. Let's see why. So plug in 3/5 way back here. 5 times 3/5 is 3. 3 minus 4 is -1. So -1 to the n over n cubed. That converges by the alternating series test. It's alternating. Absolute value of a sub n is decreasing. A sub n approaches 0. So color this in. Then I plug in 1. Where am I? Here. 5 times 1 is 5. 5 minus 4 is 1. 1 to the n, well, 1 to the n, 1 to anything is 1. Summation 1 over n cubed. That also converges because it's a p series where p equals 3. That's greater than 1. So close, close. So radius of convergence is 1/5. Interval of convergence is bracket 3/5, 1 bracket. And there we go. Okay, and folks, I am done. I am going to mark off 11.8. And I wasn't supposed to finish 11.8 until next week. So I'm actually a whole week ahead or 3 days ahead. I can really afford to slow down, I guess, which means, I'll very likely end all the classes from here on out and, pretty early, but we'll see how it goes. Okay, so that's about it, folks. Let me stop the share and see if there's any questions. And if not, we're done. I'll let you get started on the quiz. So let me check the chat. Okay, I see nothing in the chat for now. Okay, any other questions, please? Otherwise, I'll let you go on the quiz. All right, so that's it. Have a good weekend. Do it 11:59 p.m. the quiz, and we'll see you next time. Okay, bye, everybody.